For a more robust measure of spread, we turn to variance and standard deviation. These two are closely related, and are the most common ways to describe data variability. Let's break it down. Variance measures the average of the squared differences from the mean. To find it, you first calculate the mean. Then, for each data point you subtract the mean and square the result. We square the differences to make them all positive, and to give more weight to values that are far from the mean. Finally, you find the average of all those squared differences. That number is the variance. Now the variance is in squared units, which can be hard to interpret. So, we take its square root to get the standard deviation. The standard deviation is powerful because it brings the measure of spread back into the original units of our data. It tells us on average how far each data point is from the mean. A small standard deviation means the data points are tightly clustered around the mean, they are consistent. A large standard deviation means the data points are spread out over a wider range of values. For example, if two classes have the same mean test score of 80%, but one has a standard deviation of 3 and the other has a standard deviation of 15, we know the first class performed much more consistently. So, let's quickly recap. When you need to describe your data, you have a full toolkit. For finding the center, use the mean for symmetrical data, but switch to the more robust median if you have outliers or skewed data. Use the mode to find the most frequent value, especially for categorical data. To understand the spread, the range gives a quick snapshot, but the standard deviation provides the most meaningful and widely used measure of how consistent or variable your data truly is.